Hi GOR, this is Unit 1, Lesson 3, and today we're going to learn about angles. So you already know about certain types of angles, but let's really talk about how to name an angle and what is an angle. So an angle is a geometric object created by two rays. Remember, a ray has an endpoint and then it continues indefinitely in one direction. So an angle is a geometric object created by two rays with a common endpoint. So basically I have ray BA that's going like this. And then I have ray BC. So my common endpoint is B, and then I have my two rays. So the common endpoint is called the vertex, and in this angle it would be B. To name an angle, I use the three letters that are there. The middle letter always has to be the vertex. So I can call this angle ABC, or I can call it angle CBA. But notice that B, that vertex, is always that middle letter. Sometimes I can actually just use a single letter if there's only one angle located at that vertex. So in this particular case, I can call this angle B. If I had multiple angles sharing a vertex, like if I had something like this, I can't call this over here angle B because I don't know if B is talking about this angle on the right or this angle on the left. So if there's only one angle like our picture, at the vertex, I can use this single letter and call it angle B. I can also sometimes just throw a number in there and I can call that angle 1. That's probably the easiest thing to do. Now, angles are measured in degrees. So the measure of an angle is the amount of degrees needed to rotate one of the rays about their shared point so that it lies on top of the other angle. So if I was to take this ray BC and rotate it, how many degrees am I rotating it so that it lays on top of that other ray? The measure of the angle is symbolized by M, so I use this M, the measure of angle B, or the measure of angle ABC, or the measure of angle CBA. Now we already talked about the other day about the different types of angles. Our first one here is an acute angle. So this is the one that is less than 90 degrees. Remember, 90 is that L shape, and this is obviously less than 90. If it's more than 90, we call that an obtuse angle. So that's greater than 90, but less than 180. And we already talked about these the other day. And then, of course, our right angle. Remember to know that it's a right angle. We'll look for that little symbol right there to show us we have this L shape going on. So a right angle is exactly 90 degrees. We also talked about the other day a straight angle. So that looks like a straight line. A straight angle is exactly 180 degrees. This one we didn't talk about because it doesn't come up that much, but it's actually more than 180 degrees, and we call that a reflex angle. More than 180 degrees. All right, so those are our different types of angles. Let's practice just naming them, talking about them, their parts. So if we look at example 1, name the vertex of the angle. Remember, the vertex of the angle is where those two rays meet. So my vertex of the angle is right here at K. The sides of the angle are my rays. So KL is one ray, KL. And my other side is KJ going this way. They share that vertex. They share that K. And then how can I name the angle? In this particular case, there is just one angle, so I can use that middle letter and I can call it angle K. If I'm going to use the three letters, I would call it angle LKJ. Remember, the K has to be in the middle. Or I could call it angle JKL. And the last part is, what kind of angle is this? Is this angle 90 degrees, less than 90, more than 90? Remember, 90 is this L shape that looks like that. So this is obviously more than 90 degrees, but it is less than 180. So I would call this an obtuse angle. All right, if we want to flip it over, we got another practice. Example 2. So if you want to, you can pause the video and you can try to do this on your own if you want, and then you can play it again to check your answers. I'll go through it slowly so that you can do it at the same time. So I want to name the vertex of angle 2. So angle 2 is right here. I'll trace that in green right there. The vertex is where the two rays meet. So the vertex of angle 2 is T. The sides of angle 4. So angle 4, let me grab another color. Angle 4 is right here. The sides of angle 4 would be TW. Remember, the sides are made up of rays. I'm always going to name the end point first, and then in the direction of the W it goes forever and ever, and then TZ. Another name for angle 3. So let's get rid of some of this right here. So angle 3, I'm talking about this angle right here that I have highlighted in orange. So I cannot call it angle T, okay, because there are other multiple angles going around at that vertex. But I would just use the 3 letters. Make sure the T is in the middle. So I can call it angle UTZ, or you can call it angle ZTU. So whichever one, you don't have to write both answers. But I'm just telling you that there are 2 possibilities right there. But notice that T is in the middle. Another name for angle 1. So angle 1 is right here in green. Okay, again, I can't call it angle T because that would be confusing. There are multiple angles there. So I'm going to use the 3 letters that are there. Remember, the T has to be in the middle, so I can call it YTX. Angle YTX. Or I can call it angle XTY, whichever you prefer. Now I want to classify angle YTW. So let me erase this so we can look at that. Angle YTW. So YTW looks like this. YTW. There it is. And if you guys are noticing, hopefully, that symbol there. So that symbol, I mean, it looks like a right angle, but unless that symbol is there, we don't know for sure. So that is, in fact, a right angle. Then I want to look at, let me grab another color here. Grab the blue. Angle YTU. So YTU, YTU is this one right there. Now, if this is 90 on this side, then angle 1 is 90, but YTU is bigger than that L shape. It's bigger than 90, so this would be an obtuse angle. I'm classifying them right now. I classify them by how many degrees they have. And then let's see, pick yellow, angle XTU. So XTU is this right here. They're talking about really angle 2. You can see that it's less than 90 degrees for sure, so that would be an acute angle. And then my last one, make sure I didn't run out of colors here, angle WTU. So where's my W? WTU. And I'm talking about this angle in here. So it is obviously more than 90 because I know that this right here is 90. Now how do I know that? This was 90 because of the symbol, but this is a straight line right here. So together, these 2 angles, angle 4 and angle 5, have to add up to 180. So WTU is more than 90 degrees. It is an obtuse angle. Okay, we got this problem down here. Example 3, so I have this drawing and not drawn to scale. Answer each of the following questions based on the diagram. Each portion of the problem is independent of the others. So A does not depend on B. They're 2 totally separate problems, but based on the same picture. So the first thing I have is I have angle KJM. So KJM is, let's see, KJM is right here. KJM, so I have that, is 22 degrees. And I have angle KJL. So KJL is this one right here. These are adjacent angles because they lie next to each other, is 84 degrees. And then I finally want to know what angle MJL is. So MJL is both of these together. Okay, so the smaller one is the green one, and then that bigger one up on top is the orange one, but I really want to find MJL, which is both of these together. So all I'm doing is adding the 84 and the 22 together, and I get 106 degrees. All right, I'm going to erase this so then we can try the next one. Okay, so angle LJM. Now LJM, remember, is this big total, both of them together. The outside one is 145 degrees. So all together, this right here is 145 degrees. Then I have angle KJM. KJM is this guy right here. So that one right there is 48. And I'm trying to find out angle LJK. I'm trying to find this one up here. So I know both of them together are 145. The smaller one on the bottom is 48. And I'm trying to find this one on top. I'm going to take 145 and subtract 48 is 97 degrees. Okay. And last question, why can neither of the angles measured in parts A and B be labeled as J? Why can't I call the top angle or the bottom angle or the whole angle together angle J? And that's because more than one angle shares point J as its vertex. There are multiple angles going on in that picture. If it was just one single angle, then absolutely you could call it angle J, but if there's more than one angle, then you cannot do that. And we have one more page, and that's to go over our angle relationships, our angle pairs. We also define these. We're just going to look at them again because tomorrow we'll be practicing some problems with them. So if we look at that first one up here, vertical angles. So vertical angles are two angles across from each other on intersecting lines. So if I have two lines that intersect like this, okay, they just cross, they don't have to cut each other in half or anything like that. I have four angles that are formed. The angles that are opposite each other, like angle 1 and angle 3, those are vertical angles. Angle 2 and angle 4, those are vertical angles, and vertical angles are congruent to each other. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. All right, so those are vertical angles. We'll go around in a circle right here. So the next one I have linear pair. Notice the word line in linear and pair meaning two. So these are two angles that form a line. So if I had something like this with angle 1 and angle 2, those form a linear pair. Since they form a linear pair, since they form a line, they're going to be 180 degrees together. So that's similar to the one down here, and those are supplementary angles. Supplementary angles also add up to 180 degrees. So supplementary angles can form a line. They can look like this. If I have these two angles, 130 and 50, they form a line. Those are a linear pair also, or they can be totally separate angles not touching. So I can have one that's 130 and one that's 50, and together those are supplementary. So supplementary angles can be a linear pair. A linear pair is always supplementary. Complementary angles. Complementary angles add up to 90 degrees. So any two angles that add up to 90 degrees, again, they could be touching each other, sort of like these two. Those are complementary. They add up to 90. Or they could just be two angles that add up to 90 that are not touching each other. Either one. Okay, so those are complementary angles. Complementary adds up to 90. Supplementary adds up to 180. So I remember this. C comes before S in the alphabet. 90 comes before 180. Okay, I've seen some people say to remember like the C in complementary, you can make a 90 out of it, and the S in supplementary, you can make a 180 out of it. So however you can remember it is fine. And then my last one are adjacent angles. So adjacent angles are just two angles that share a side and they share a vertex. So angle 1 and angle 2 are adjacent angles. They don't have to be congruent to each other. They're just sharing that side in the middle. So they're sharing this side right here, and they're sharing the vertex. They're next to each other, and those are adjacent angles. Okay, so you're going to practice. You're going to do the homework tonight, and we're going to practice some more tomorrow with all of these different kinds of angles. The vertical, the supplementary, the complementary, the linear pair, and the adjacent angles.